In today's video, we will be demonstrating a static check that we will perform on a device called an AC solid-state switch, and that we find on many boards today. So on this printed circuit board, you see a number of AC solid-state switches. These are also called, in some cases, AC solid-state relays. The task that this performs is when the logic section of the board gives commands or signals for things to switch on and off, these relays do so. The switch happens on the LED side. And we've got a diagram. So when this LED here is turned on, the switch happens here on the AC load side. This is great for some applications because there's no connection, or it's an isolated connection between what's giving the signal and what is switching. This prevents transient voltages and other sorts of problems that could cause electromagnetic interference and could disrupt the operation of mechanical relays that are attached to this output here, and in this case along this connector. So wires going out to the machine could be interfered with if they had regular relays. So that's why these solid-state relays are important. In order to do a test, we must enable the relays on the LED side and watch for a state change on the output side, which is here, or the load side as you call it. Now we are going to hook up the load side and we will get a resistance value on the meter. In this case, 6.6 mega ohms. Now, when we excitate or turn on the diode side of the solid-state switch, we should see a drop in resistance, and that way we know it is good. So here, we are going to go ahead and add our signal using our Huntron tracker. We can see that we are getting a good diode waveform. And when we add this, we are seeing a drop in resistance. Each time we take away the probe and put the probe there, we see that this switch is functioning. It is doing its switching. So now we will move on to one that we have found to be bad. So we're going to go ahead and connect up the load side. There we go. And immediately we see we have a problem. We're actually only getting 10 ohms. That would indicate that the AC load side of this particular switch is shorted. We can also try to turn the switch on using the internal diode, and we still get very, very minute change, and at a very low ohmic value, which tells us that this is more than likely shorted internally. We have our load hooked up. We can actually see that the diode side of this IC is actually still good. You can see that whatever shorted this particular IC did not short the diode internally, which is a factor of the IC being electronically isolated internally. And this is one of the strengths of this particular component, that it didn't damage anything else on the load side. So this component will have to be replaced and other components checked throughout the board and then repaired. Then this repaired board will be shipped back to the customer. Thank you for watching. For more videos, subscribe to our channel.